Doing page 87, 1 through 15, 20 through 22, 28 bonus. So, what is different about these problems today?
Something. Yes.
They have fractions and decimals. So, what we're going to do, our plan of action here is to try and get rid of the fractions or the decimals to make the problem simpler. Okay, so if it's a fraction problem like this, you look at the denominators and ask, what do all the denominators go into? What do 3 and 4 both go into? 12. So what I'm going to do is multiply both sides by 12. That's a legal algebra move, right? So every term on both sides gets multiplied by 12.
What? Oh, it's 3 times 3.
Now, why am I doing that?
Huh?
Because 12 over 3 reduces. 12 over 4 reduces. And that'll get rid of my fraction. What's 12 divided by 3? 4. So I have 4 times x is 4x. What's 12 divided by 4? 3. So I have 3 times x. I'll write it in there. So that's 3x. So 4x minus 3x equals, this one doesn't have a denominator, it just has 12 times 1, which is 12.
Wait, are you doing odds with this?
Yes. So now I've got an equation that's a lot simpler looking. What should I do next? Subtract like terms. 4x minus 3x is 1x equals 12.
That was fun.
All right, let's see if we can repeat that.
No.
Number 3
No. No. I didn't
says,
Everyone say no.
Favorite word to say.
Oh, I feel like math is so fun.
No.
Something's wrong with you.
No.
Yeah.
Might want to get that checked out.
But nobody understands it.
all right,
I know what to do first.
you guys remember what we did first on the last problem?
Yeah.
Found the line denominator fractions.
What do 9 and 3 both go into?
27.
Okay, this is,
Really?
by the way, this is the same way you start an adding fractions problem. You look for a least common denominator, but we're not trying to actually change the denominators, we're actually trying to get rid of the denominators. So 9 and 3 both go into 9. I'm going to multiply everything, every term on both sides by 9. Why am I only multiplying the top by 9?
Because you're trying to get rid of the denominator.
Well, yeah, but when you multiply by 9, really you're multiplying by 9 over 1. So if it's on a fraction, you just multiply the top, not the bottom. Okay, what am I going to do? So you could do 9 times 2 divided by 9. That would work. But it's usually a little easier to reduce first. 9 divided by 9 is 1 times 2x is 2x. Board looks like checkers. 9 divided by 3 is 3. 3 times 1 is 3. And then 9 times 5 is 45. Now we got a normal problem.
21.
Y over 2 minus 2y over 7. Equals 25 over 7. Alright, what's our first step again? I forget.
Find 14.
You don't forget, you just want to.
You find the denominators like 14.
2 times 7 is 14.
The
Okay.
least common denominator.
Yeah, they all go into 14. Fourteen divided by 2 is 7. So we have 7y minus 14 divided by 7
Two.
is 2 times 2y. Whoops, I put equals instead of minus. Minus 4y equals 14. Now, like I said, you could do 14 times 25 divided by 7 on your calculator, but it'd be a lot easier to do 14 divided by 7, which is 2, times 25.
Oh, which is 50.
That way you can do it without a calculator. And now what?
7 minus 4.
7y minus 4y is 3y. Uh-oh, this is a messy one. But we do not fear fractions. We don't need a calculator for this.
Yeah.
How do I use, what's my last step?
What? Right.
Divided by 3. What's 50 divided by 3?
16.6 for
No.
Oh.
Let me figure it out. It's math.
50, you guys should know this by now.
16.7.
50 thirds, right?
Oh.
50 divided by 3 is 50 thirds.
We should have seen it.
50 divided by 3 is nothing.
That's why you don't need calculators.
Cool.
Which are cool for calculators.
No, well, you're not.
Now, if it was 51 divided by 3, you might want to plug that in the calculator, 'cause that actually does divide. That would be 17. Number 7. B over 3 minus 8b over 7.
Go.
68 over 21. Oh. 1, 2, 3, 7, and 21 go into
21.
21.
21. 21.
Oh, I knew someone was gonna say it.
21, 21, 21. Okay, 21 divided by 3. 7b minus 21 divided by 7.
16. Not
3. 3 times 8b is 24b. 21 divided by 21 is 1 times 68 is alright. 7b minus 24b.
Negative 17.
Be a good time for a calculator. 16 divided by negative 17. Oops. B equals negative 4. Do these problems seem doable? Okay, number 9, y equals 3y over 5 plus 12. I remember it right. Yes. What do I need to multiply by? 5. Alright, this is Friday's assignment. What do we do when we have y's on both sides?
You subtract what they
Subtract
say.
3y. Get your y's at one side by itself.
And now 60 divided by 2.
60 divided by 2 is
30.
You okay?
Cool.
Math is being fun.
Not really.
We're,
Except Mr.
Okay.
Gordon makes it fun. Right, Mr. Gordon?
sure. Number 11. Are you guys done with that one? Let me write it down, I guess. 2b minus 8 equals. Whoa. Oh, my email. What's that? Go away.
I'm a mark. Beam a ball.
2b minus 8. Okay, so on decimals, they're actually quite a bit easier. You don't really have to get rid of a decimal. How would I solve this normally?
I know.
You got b's on both sides.
You subtract.
Subtract 2b, and then you'd have negative 8 equals like negative 1.6b, and you divide by negative 1.6.
Oh, cool.
Okay, so we don't really have to get rid of decimal, but just for practice sake, we're going to get rid of them on this assignment. Do you know how to turn a 0.4 into a 4?
Yeah.
Well,
You
move the
time,
decimal
yeah.
to the right once, but
but you times on every side.
yeah, we're multiplying everything by 10 when we do that. If
Exactly.
you multiply by 10, the decimal moves once. If you multiply by, how do we move the decimal twice? 100. So on this one, we just have one decimal place, so I just multiply everything by 10. So you probably don't need to write this, but it's basically this is what we're doing. 10 times 2b is 20b minus 10 times 8, 80. 10 times 0.4 is 4. So no more decimal place, or no visible decimal anyway. Now, what do I do if b's are on both sides? Subtract. Since the only thing I have in right is the b's, I'm going to move everything away from the left. 4 minus 20.
-16. B. Forgot to add it.
Divided by negative 16.
I think there was one even question.
All right. How many decimal places do I need to get rid of on 13? 2. Because we have the 0.09y and the 1.49. Okay, so technically what we're doing is we're multiplying everything by 100, but really I'm just moving the decimal place twice on everything. So what's it going to become? What's 1.4y going to become if I move the decimal twice?
140.
Right. So 1.4 becomes 140. 140y plus what? 9y equals 149.
Oh.
It looks a little less scary than the original, I guess. Maybe 140y plus 9y is 149. Okay, how many decimal places do I want to get rid of on number 15?
3,
3. So what am I multiplying by on 15?
1.
1,000. I'm not going to write 1,000 down. I'm just going to move all the decimals 3 times. But you got to be careful. It's easy to get one of these numbers a little bit wrong. So on 15, the first term, 0.3x, if I move the decimal 3 times, 300x. Plus 890
It is not.
equals 5321. It's like counting backwards, but you failed.
It's like a 5-year-old counting backwards. The comma's actually 4.
Yep.
Counting by.
Okay, so this one we got a basic problem, although the numbers are pretty big, so might be a good time for a calculator. Minus 890. What does that come out to?
Oh, I
4,430.
I just got hit here.
I almost had to register.
Okay, so since this was a decimal problem to start with, the book put a decimal answer. So I'm not going to leave 4431 over 300. Let's go ahead and divide it. What do you guys get?
Big 14.77.
14.77. Okay, on to the challenge round, number 21. Uh-oh. My book's falling apart. It's trouble. Got another one somewhere. Okay, 21. Look at that dude.
What?
Scared of him?
It is kind of scary. It's definitely more tremendous.
Fortunately, 21 is the hardest on this back section
Yay.
because it's got 2 new tricks that we haven't done.
What did you say? Fortunately?
Are you sure you can do 20 and want to do?
20 and 22 are a little bit slightly easier, but they're almost the same. So what do you guys think step 1 is going to be?
Common,
That thing.
Which is,
8.
8.
we're going to multiply everything by 8, but this was just got. So when we multiply that first term by 8, when we multiply that first term by 8, it's really not the a we're supposed to multiply by 8. It's really all of it gets multiplied by 8. But I'm not going to multiply by 8 yet. You guys know what I'm going to do?
Something.
Okay, we could multiply those first and then divide them both by 2. That would work. But I'm going to divide first, just like we did on the first problems. So 8 divided by 2 is 4. So then I can multiply both of those by 4. And what would that be?
4a minus 12.
4a minus 12. Okay. So we did trick number 1. We got to multiply every term in the numerator. Trick number 2 is upcoming. This minus right here, what are we subtracting? All of this. Okay? So when I do 8 divided by 4 is 2. Maybe I should put it down here. We got to subtract 2 times all of this. Like that. So really, Yeah, think of that as a negative 2. So what would that give me?
Negative 2a
Plus negative 6 or
or
minus 6. Plus a, that's an a, not a 9, equals 8 times 6.
48.
Okay, we got rid of the fractions, which made it a lot better, but we still got a lot of, kind of a big mess, don't we? Yeah, like terms can go together, right?
Negative 4a.
So I see 4a minus 2a
Plus 1.
plus 1a.
3a.
So yeah, 4 minus 2 is 2, plus 1 is 3. I also see a minus 12 and a minus 6.
Minus 8.
Negative 12 minus 6 is negative 18. So minus 18 equals 48. Now we got something that looks comfy.
Add 2.
Comfy. I believe that is 66.
Yeah.
Divided by 3.
22. Big number.
It's not.
Also, I just want to point out, I actually like 22.
It's not.
Okay, so in the next couple minutes, I'm gonna come around and check you guys' number 2.
Okay.
I think I still remember it.